All right, so for this question, this type of question you would see on the GMAT, on the SAT 2016, the brand new SAT coming up in 2016. Just giving you guys a sample of the kinds of question students will be required to be able to handle. So you look at this, this question kind of uses a lot of quadratic equations and just really high-level algebra. So if you take a look at this, you notice something very interesting here. You see these two parentheses here, ax plus 2 and then bx plus 7 on the left side, and then they're saying that is equal to this side. Well, anytime you see this in math, just go ahead and process that left side. Okay, we're going to go ahead and process that and just multiply through the process called foiling. Okay, so 12x plus cx plus 14. Okay, so I'm going to focus on this left side for a minute. I'm going to say ax times the bx is going to be abx squared. And then we're going to say ax times the 7 is going to give us plus 7ax. And then I'm going to say 2 times the bx, which is going to be 2bx. And then 2 times the 7, which is going to be 14. All of this is equal to 15x squared plus cx plus 14, okay, is what we have. So with this said, something comes up because most students are able to at least FOIL this side and make it equal to this right side, but then they don't know what to do next. Well, one of the things you notice here is, hold up, it seems like we have the same types of things. The keyword is types on both sides. Check this out. We have x squares on both sides. So like this 15x squared is like this abx squared, okay? And then we have x's on both sides. I'm going to use a different symbol to kind of distinguish the x's. So you notice that these are x's. I have it on both sides. And then we have constants, 14. As you can see, they match it. They match. So in math, at this point, because they're equal, you can make those types equal to each other. So I can write an equation set that looks like this. abx squared is equal to 15x squared. That's one equation. I can also write another equation that says 7x plus 2bx. Where am I getting that from? That's this, the wiggly one, this one. ax, that should equal to the what? The cx, because I'm using these signs, the straight line, the wiggly one, and the circle, to distinguish that those types go together. So this should equal to this. And then eventually, obviously, the circles are equal, which makes sense because 14 is 14, okay? So that is not really going to give us much, but that is true. All right, so based on this, do you see that if this is x squared and this x squared, that cancels out? And so I just have AB is 15, so that we know. Now over here, the x that is common here can be factored out. So we can have x factor, that's going to be 7a plus 2b is equal to cx, okay, cx. So that's true. And then obviously, as you can see, the same way, that crosses out because it's common on both sides. So essentially, 7a plus 2b is c, okay. Now the question tells us something interesting. It does say that a plus b is x, a plus b is x. So how about we put that right with this guy? The reason is because in math, if you have two unknowns, a, b, and two unknowns, a, b, you need two equations to figure out what a and b would be. So and we can do that here. So how about we go ahead for this top one? Well, actually, this bottom one probably is even easier. Why don't you go ahead and solve for a? So a is 8 minus b. Okay, just bring this b over to the right side. And then take this 8 minus b, take it right here, and plug it in there, okay, in place of this a. So instead of saying a times b is equal to 15, you would say 8 minus b, yes, times b is equal to 15. We can say that. And then run this b through. So this is 8b minus b squared equal to 15. All right. So obviously at this point we want to get, this is looking like a quadratic equation, all right, which means we have b squared, we have b and 15. Now obviously you always want your b squared to be positive. So in this case I'm going to move everything to the right side and make it equal to 0. So if I move everything to this side, I am essentially going to have a setup that looks like this. I'm going to say, I'm going to have b squared. I'm going to move the 8b to the right as well. It's minus 8b. It is plus 15. All of this is equal to 0. And obviously you can switch this around to make it look more like this, which is still the same thing as long as it's equal to 0. Okay, so now this is a quadratic equation. One of the things that we're really emphasizing on this new SAT in your Heart-of-Algebra type questions. So I have to create two parentheses, and now this is how you solve. Anytime you get a quadratic equation, create two sets of parentheses. And then take a look at this 15, okay, for a second. So I'm going to look at this 15 and say, what are two numbers when multiplied would give me 15, but if I added or subtracted them, I can get an 8 out of it? Well, that would be 3 and 5, because 3 times 5 is 15. But if you added or subtracted 3, well, if you added 3 and 5, you would get an 8. But obviously, we want a minus 8. So we need to have a minus 3 here and a minus 5, because minus 3 minus 5 is plus 15. But minus 3 plus minus 5 is also minus 8. So it does two things using those two factors. So because it's b squared, this is a b squared, this is going to be b and b. I'm going to bring the minus 3 there. I'm going to bring the minus 5 there. And obviously, based on what we have here, both of these are equal to 0. So I would have to say b is 3 and b is equal to 5, because they're equal to 0. So you can move the minus 5 and the minus 3 up, to the other side. Now, if you look at this question very well, it did say, what are the two possible values of c at the top? Which means, and this makes sense, because if you're going to get two possible values of c, remember c is actually 7a plus 2b here. So I need two values of each to produce more than one value for c. So I already have two values of b. So can we solve for a now? Let's go back here. Remember we said a is 8 minus b. Well, if I know my b is 3, I'm going to take this first b, put it here. So 8 minus 3, a will be what? 5. So a is 5 there. And for this a, I'm going to take that same 5, put it in this equation of a. 8 minus 5 is 3. So that's going to be 3. So now I have my two sets of values. So we're ready to finish this question now. I'm kind of getting tired of the question already. The c is what? 7a plus 2b. Well, all you need to do now is, well, just plug in your first set. So we have a set here and a set here. The first set here says the a is 5 and the b is 3. So I'm going to use that. The a is 5 and the b is 3. Well, if you process this out, this is going to be 35 plus 6, which is what? 41. So your first value of c is 41. Now, you need to be sharp and fast on the SAT. The moment you got this value of 41, look at the answer choice set. There's only one of them that has 41 as an answer. Your answer is D. You don't even need to really solve for the second one. I'm going to do it. But you don't really need to, because you already found 41. There's only one thing that has 41. If there's more than one thing that had 41, then obviously you want to go ahead and figure out the next one. But there's only one thing. There's only one answer set, that answer choice that has 41. So we're just going to go ahead and pick D. But just to finish this question out, if I plugged in this set of A and B here, it would be 7 with the 3, and it would be 5 with the B that I'm using, which is 5 there. And this should be 21, this should be 21, this should be 25, and this is, I did something wrong. This is not 5 times 5, this is 2 times 5, 2 times 5. This is actually 10. Okay, so it's 21 plus 10, which is 31. So as you can see, it confirms that D is the answer. So this is how you do a question like this. It's pretty long. It's a question deep into the new SAT. I hope you guys kind of pick from this new SAT. They're really requiring students to really know their stuff and testing some really deep areas of their algebra and stuff. And this is an example of a question like that. So see you soon.